Okay, so what we're going to do is we're going to continue with our understanding of angles in both degrees and in radians. Now, in order to move into the next thing that you're going to need to understand, what I want to do is I want to get your brain ready for something by introducing you to angles on the coordinate plane. Okay, so the Cartesian plane, right? So we've got the x-axis here, we have the y-axis here, and one of the things we do is we identify angles that are happening that start where the angle exists at the point 0, 0, at the origin. Okay, now I already introduced you to the idea of the initial side, right? And so here's the deal. In what we're about to learn and in the next several lessons, you need to understand that the initial side is always on the x-axis on the positive side of the x-axis, right? So all the negative numbers for x are over here, and all the positive numbers for x are over here, counting up to infinity, right? Well, the initial side of the angle that we're dealing with starts at the point 0, 0 on the coordinate plane, and it extends along the x-axis in a positive direction towards positive infinity. Now that side of the angle does not move. It doesn't move at all. Then the second side of the angle, which we call the terminal side, and I'll write that down in just a second, it starts at the initial side. It starts out right on top of the initial side, and then what can happen is this, what you saw in the last couple lessons is that it opens up the angle by turning up from the initial side, and it can go all the way over here, and it can go all the way back here, and it can come around, and it can meet up with the initial side again, making a 360-degree angle, okay? So when this terminal side opens up, so let's say that it opens up to right here, this is what we would have. And so let's say it opens up to right here. We can draw that. We will call that the terminal side, right? And what's happened here is, so we put this little curve in here to show how far the angle has opened up, right? Like I said, the initial side is going to stay right here, and then the terminal side is going to open up. It's almost like a hand on the clock. It's like this hand on the clock is stuck pointing at the 3. Okay, but this hand on the clock is opening up, and it's turning. Now you can see that this one is turning counterclockwise. It's turning backwards according to a clock, but it can also go this direction, and that's one of the things that we're going to talk about in this lesson. But it opens up, and then we can measure this angle as being a certain number of degrees or a certain number of radians. And you learned how to convert between degrees and radians, so it doesn't matter whether I give it to you in degrees or radians, you can calculate the other one, okay? So the terminal side, now it doesn't have to be right here. The terminal side you've already seen in previous examples where we had the terminal side, it opened up, it went up and around, and let's say all the way over to here. But it can actually also go all the way over here. Let's say that the terminal side, let's say that the terminal side went to here, all right? And let's say that it opened up all the way from here around here. That's a pretty large angle, okay? Now, here's what one of the things that we're going to review is the fact that when we go from here up to here, that's 90 degrees. And then when we go to here, that's 180 degrees. And then down to here, if we add another 90 degrees to 180, that's 270 degrees. And then another 90 degrees, and we have 360 degrees all the way around. Well, this angle didn't go all the way around, so it's less than 360 degrees, but it's larger than 270 degrees, okay? And one of the things that we're going to do in this lesson is I want you to be able to identify which quadrant the terminal side is in. So what we're going to need to review is the names of the quadrants. Okay, so we use Roman numerals, but we call this quadrant up here, the positive quadrant, is called quadrant 1. The negative positive quadrant is called quadrant 2. The negative quadrant is called quadrant 3. And the positive negative quadrant is called quadrant 4. Okay, so we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right? So in this particular case, if I asked you what quadrant is the terminal side is, and here's the terminal side, what quadrant is the terminal side in? Well, it's in the 4th quadrant because it is between here and here. It's pointing that way. Any terminal side that's somewhere between here and here is in quadrant 1. Any terminal side that's between here and here is in quadrant 2. Any terminal side that's between here and here, somewhere in here, is in quadrant 3. And we've already said anything in here is in quadrant 4. Now, you may be asking, well, what happens if it's right on one of the lines? Well, if it's right on one of the lines, it is not in any of the quadrants, and then you would say that it's not in any of the quadrants or none of the quadrants. Okay, or you could say that it is on the y-axis or on the x-axis. Okay, but we're primarily going to focus on. I'm primarily going to give you questions where the answer is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. So what I want to do now is I want to identify the angle measures in degrees and radians that are on the x-axis here and here, and on the y-axis here and here. So let's do that right now. All right, so let's start with x right here, okay? All right, well, if the terminal side is right on top of the initial side, if they're both right on top of each other, then we don't have an angle at all because the terminal side has not opened up at all. And therefore, having no angle is the equivalent of 0 degrees, a 0 degree angle. Now, we're going to now convert that 0 degrees into radians. So we're going to take 0 and we're going to multiply it by pi over 180. Okay, well, 0 times anything is equal to 0, right? And therefore, this is going to be 0 radians. So we can say that it's 0 degrees or 0 radians. Okay, so whenever your angle, your terminal side, is right on the x-axis, and it has not turned at all, because what we're going to see in just a little bit is that the terminal side can open up and it can come all the way around and then sit on the initial side again, but it has created an angle. I'm talking about a situation where it has not opened up at all in any direction and it just stays sitting right on the initial side. We say that that angle is a 0 degree angle or a 0 radian angle. Okay? All right, so now what if the terminal side opens up and it goes vertical, so that the terminal side is right here. Let's see here. So let's say the terminal side is right on the y-axis. Okay? Well, what kind of angle have we created here? Well, that's perpendicular, right? The y-axis and the x-axis are perpendicular, and therefore it creates a right angle. And we know that a right angle is a 90 degree angle, right? So when the terminal side is going straight up, when it has opened from here over to here, that is a 90 degree angle. So this is going to be 90 degrees. And now let's convert 90 degrees into radians. We'll do 90 degrees times pi over 180. Well, that would be 90 pi over 180. And we can cancel out the zeros if we divide by 10. Then we can divide by 9 in the top and 9 in the bottom. And we wind up with 1 pi, or just pi, over 18 divided by 9 is 2. And therefore, a 90 degree angle is the same thing as pi over 2 radians. Okay? All right, so now let's keep going. We're going to go now to the negative side of the x-axis. So let's say that the terminal side opens up from here all the way over to here, and it creates a straight line. So if the terminal side is over here, it does this. That's a straight line, and a straight line is 180 degrees, right? So this over here, this is going to be 180 degrees. And if we now identify how many radians 180 degrees is, 180 times pi over 180. Now, we already know this because we did it in one of the previous videos. The 180 and the 180 cancels, and all we have left now is pi. So that is pi radians. So here, 180 degrees is the same thing as pi radians. And now we're going to come down here. Let's say that it opens up. The terminal side opens up. It goes past 100 or past 90, past 180, or past pi, and then it comes down here, and it creates another what looks like a 90-degree angle. It would be a 90-degree angle if it opened backwards. If it started here and went this way, then it'd be a 90-degree angle. But it actually started here and it came around here. Well, we know that from here, from 180 degrees down to here, that's 90 degrees, right? That's a right angle. That's perpendicular. So really what's happening here is we've got 180 degrees plus another 90 degrees. That's 270 degrees. So when the terminal side is going straight down, if it's opened counterclockwise, this is a 270 degree angle. So we're going to put 270 degrees. And if we convert that into radians, we'll do 270 times pi over 180. That gives us 270 pi over 180. The zeros can cancel if we divide by 10 in the top and the bottom. 27 can be divided by 9. 18 can be divided by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So what we have is 3 pi over 2. So this point right here, this angle here, in addition to being 270 degrees, is also 3 pi over 2 radians. And then lastly, what if the terminal side opens all the way? What if, let me redraw this initial side here. Oops, it's pretty ugly. Oh well, we'll just deal with the ugliness. If the terminal side starts here and it opens, goes to 90, goes to 180, goes to 270, and then it keeps going and then meets back up with the initial side so that it's sitting on top of the initial side, well, it did this. It made a full circle. And a full circle, we know, is 360 degrees. So, at this exact same place where we had 0 degrees, we also have 360 degrees. And if we were to convert 360 degrees into radians, we would have 360 pi over 180. Cancel the zeros. We have 36 divided by 18. Well, that's 2. And so what we have here is 2 pi. Now, we already learned that the circumference of a circle is 2 pi, which is the same thing as, well, 2 pi times the radius, which is the same thing as 360 degrees. It's a full circle. Therefore, 360 degrees is the same thing as 2 pi. What that also means is this, is that 360 degrees is basically the same thing as 0 degrees on the coordinate plane. Whether we open the terminal side up all the way to where it started, or whether we don't open it at all, the terminal side ends up in the exact same place. It ends up at 360 or 0 degrees. That also means that 0 radians and 2 pi are basically the same thing as well. Okay, but we'll get into more of that later on. Okay. All right. So now what I want to do is, now that we have the measures for each of the axes, here's what we can basically understand is this, is that quadrant 1, any angle theta, okay, any angle theta that is between 0 degrees and 90 degrees. So if we start at if the terminal side starts at 0 degrees and goes anywhere up to 90 degrees, but not at 90 degrees. If the angle is between 0 and 90 degrees, then the terminal side is in the first quadrant. We can also do that in radians. 0 radians up to pi over 2. So if we have 0, if the theta angle is between 0 radians and pi over 2 radians, then the terminal side is in the first quadrant, okay? The second quadrant is going to start at 90 degrees. So if the theta angle is between 90 degrees and 180 degrees, note I am not using or equal to. It has to be larger than 90 and less than 180. Or in radians, it would be between pi over 2, theta angle, so greater than pi over 2, but less than pi. So if the theta angle is between pi over 2 and pi, then it is in the second quadrant. Now coming down to the third quadrant, if the theta angle is between 180 degrees and 270 degrees, so 180 degrees, that's a theta, that's an ugly theta. Let me redraw that. It's really ugly. Theta and 270 degrees, then the terminal side lies in the third quadrant. And lastly, this would be lastly, but also if we did it in radians, if the theta angle is between pi and 3 pi over 2, right? Between pi and 3 pi over 2, then it's in quadrant 3. Lastly, if the terminal side is over here, that's between 270 and 360. So if the terminal side theta, or if the angle theta is between 270 and 360 degrees, then the terminal side lies in the fourth quadrant. And similarly, in radians, if the angle theta is between 3 pi over 2 and 2 pi, then the terminal side lies in the fourth quadrant, okay? And so what I want to do now is I want to do a few examples where I just give you an angle and you tell me which quadrant it's in. All right, so what I've done is I've identified 8 different theta angles here. So let's say theta is a 73-degree angle, and we want to know where is the terminal side if the theta angle is 73 degrees. Well, 73 degrees, if we were to start at the initial side, if we went up to here, that would be 90 degrees. Is 73 degrees larger than 90, or is it less than 90? Well, 73 is less than 90. That means it must be over here somewhere. Therefore, the terminal side is over here in quadrant 1. And so what I'm going to do is I'm going to put a Roman numeral 1 next to the 73 degrees. Now we're going to do radians. How about 3 pi over 4? Well, this one is a little confusing, and there's a couple different ways that you can do a radian angle. Probably if you struggle with knowing where 3 pi over 4 is in terms of between 0 and pi over 2, or between pi over 2 and pi and 3 pi over 2, or 3 pi over 2 and 2 pi, there's a few ways that you can do this. One way that you can do it is you can convert the radian angle into degrees, and if you convert it into degrees, then you can then just look to see if it's between 0 and 90, or 90 and 180, 180, 270, 270 and 360. So if you were to convert 3 pi over 4 into degrees, it would be a 135 degree angle. And therefore you would know that 135 is between 90 and 180, and therefore 3 pi over 2 is in the second quadrant. Okay? Another way you can do it is this. You can ignore the pi. Watch this, because they all have pi in them. Another way of thinking about it goes like this. Do you see this here? If you ignore the pi, this would be 1/2. 1/2, and this is 1 because it's 1 times pi, right? So another way of thinking about it is that when the theta angle, if without the pi it's between 1/2 and 1, Well, what's this without the pi? Well, that's 3/4, right? Isn't 3/4 between 1/2 and 1? Yes, therefore it is in the second quadrant. Another way that you can do it is you can use a calculator and you can identify what pi over 2 is, which is about 1.5 something, okay? And pi is 3.141592, and if you were to key this into a calculator, you would get something between, I don't know what well, let's go ahead and do it, 3 pi over 4. So if we key 3 pi over 4 into a calculator, 3 pi, enter, divided by 4, you get 2.356. And 2.356 is between 1.5 something and 3.14 something, okay? And so then, again, you know that it's in quadrant 2. Eventually, you're going to understand what this 3 pi over 4 is. You'll start to get used to what a lot of these numbers are, okay? All right, so let's try. How about 281 degrees? Well, that's an easy one. 281 degrees is between 270 and 360. Just realized I forgot to write quadrant 2 here. There we go. 281 degrees is between 270 and 360, and therefore for this theta angle measure, the terminal side is going to be in quadrant 4. So we'll put an IV here for 4. Okay. 7 pi over 5. All right, well, let's do the thing where we get rid of the pi, shall we? Okay, so basically what this is this is the same thing as 7/5. Well, 7/5 is definitely not between 0 and 1/2, right? In fact, this number is larger than 1. If you divide 5 into 7, what you wind up with is 1 and 2/5. And 1 and 2/5 is also larger than 1. Therefore, it's either quadrant 3 or quadrant 4. Now, here's what you'd be looking at. If you get a 1 and something, if you go up to 2, if you're near 2, then it's quadrant 4. But what you're really looking at here is this 2/5. 1 and 2/5. Well, this right here, this is 1, and this one over here is 3 over 2, right? Which is basically 1 1/2, or 1.5. Well, is 2/5 larger than 1/2 or smaller than 1/2? Well, 2/5 is smaller than 1/2. In fact, 1/2 is 0.5, 2/5 is 0.4. 0.4 is less than 0.5, so we know that 1 and 2/5 is less than 1 1/2. That means that 7/5 is between 1 and 3 over 2. It also means that 7 pi over 5 is between pi and 3 pi over 2. And I know that was a little complicated. If that was too much for you, then you can try the decimal version, or you can just convert 7 pi over 5 into degrees. And when you convert it into degrees, let's see what it would be. 7 divided by 5, or sorry, it'd be 7 on the top. I know I'm doing this wrong. 7, we do 180 over pi, right? Times 180 over pi. Over 5, cancel the pi's. 7 times 180 is 1260 over 5. And we do 1260 divided by 5, and we get 252. So this is the same thing as 252 degrees. And where's 252 degrees? Well, it's between 180 and 270. And so that's, like I said, you can just convert them all into degrees to identify the quadrant. It might take an extra, 30 seconds or a minute, but it's worth getting the right answer. So this is going to be quadrant 3. Whereas 190 degrees, well, 190 degrees is larger than 180, so it's not over here. It's between 180 and 270. So this one, for a theta angle measure 190 degrees, the terminal side is in quadrant 3 down here. It would be kind of right here. This is kind of where the terminal side would be, okay? So we're going to say quadrant 3. How about pi over 17? Well, I know that pi over 17 is a very small number. In fact, I can do this one in the calculator. If I did pi divided by 17, that's 0.18. If I did pi over 2 is 1.57. So if this is 1.57 and I just got 0.18, well then it's definitely smaller than pi over 2. I can also convert it into degrees, which would be 180 over 17, which is 10.58 degrees, and that's between 0 and 90 degrees. So this one is in quadrant 1, okay? 100 degrees. Oh, 100 degrees, that's easy. That's between 90 and 180. So the terminal side is going to be in quadrant 2. And then lastly, 19 pi over 20. 19 pi over 20, that looks like it's really close to 2, right? 19 over 20, I'm sorry, not close to 2, it's close to 1. But it's less than 1, right? Because 19 divided by 20 is less than 1. So this is less than 1, but it is larger than 1/2, right? And therefore it must be between pi over 2 and pi, which is right up here. So this one is also in quadrant 2, okay? And so this is one of the main skills that you need to be able to have. Now you might say, well, what's the purpose of being able to identify the quadrant? You need to be able to identify the quadrant that the terminal side is in so that you are then able to do other skills that I'm going to add on in the next couple lessons. So make sure that you can do this and then move on. We can move on to the next couple lessons. But that's it for this particular lesson. All I want you to be able to do is identify which quadrant the terminal side is in given a particular theta angle.